July 1st, 2025. Asteroid terrestrial impact. Last alert system, Hawaii. Object designated C/2025 N1 detected at 6.4 astronomical units from the Sun. Initial classification, Comet. Velocity, 58.2 kilometers per second. Standard hyperbolic trajectory confirmed. Origin, extrasolar. Third, confirmed interstellar visitor to our solar system. August 14th, 2025. Very Large Telescope, Chile. Spectroscopic analysis completed. Composition, carbon dioxide dominant. Water ice, 4% by mass. Nickel vapor detected. Iron emissions, present. Standard cometary profile. No anomalies flagged at this stage. August 21st, 2025. Trajectory refinement conducted by NASA Jet Propulsion Laboratory. Astrometric data from 47 observatories compiled. Gravitational model applied. Sun, 8 planets. Largest asteroids included. Expected result. Predicted positions. Matching observed positions within error margins of 0.1 arc seconds. Result. Negative. Deviation detected. Observed position does not match gravitational prediction. Discrepancy magnitude 0.3 arc seconds at 3.2 astronomical units heliocentric distance. Error margins exceeded by factor of 3. Non-gravitational force detected. Confidence level 8 sigma. Probability. This represents measurement error less than 1 in 10 billion. Standard protocol for non-gravitational acceleration. Cometary outgassing. Mechanism. Volatile ices sublimate under solar heating, produce gas jets, create thrust. Expected observational signature. Visible coma surrounding nucleus. Expected spectroscopic signature. Hydroxyl radical emissions at 308 nanometers. Carbon monoxide bands. Water vapor lines. Dust continuum in infrared spectrum. August 23rd, 2025. Neil Gehrels Swift Observatory ultraviolet observation initiated. Target, S3I Atlas at 3.1 astronomical units. Integration time, 12 hours. Wavelength coverage, 170 to 650 nanometers. Hydroxyl detection limit, 2 times 10 to the 26th molecules per second. This threshold is 10 times more sensitive than required to detect outgassing producing the measured acceleration. Result, no hydroxyl emission detected. Upper limit, less than 1.8 times 10 to the 26 molecules per second. Water production rate implied, less than 50 kilograms per second. Acceleration magnitude measured in trajectory data requires water production rate of minimum 800 kilograms per second to generate observed thrust. Discrepancy, factor of 16. Cometary outgassing model insufficient to explain observed force. Additional constraint, optical imaging, Hubble Space Telescope. Observation conducted August 27th, 2025. Exposure time, 300 seconds. Spatial resolution, 0.05 arc seconds per pixel. Coma detection limit, gas cloud extending more than 200 kilometers from nucleus would produce detectable signal. Result, point source only. No resolved coma structure, no extended emission. Object appearance consistent with inactive asteroid. Yet trajectory data shows continuous non-gravitational acceleration throughout observation period. September 3rd, 2025. Spitzer Space Telescope infrared observation completed. Target, 3I Atlas at 3.4 astronomical units. Wavelength, 4.5 micrometers. This wavelength detects thermal emission from dust particles sized 1 to 10 micrometers, standard cometary dust. Sensitivity, capable of detecting dust production rate as low as 0.1 kilograms per second at target distance. Result, no detection. Upper limit on dust emission, less than 0.08 kilograms per second. For comparison, Comet 67, P/Churyumov-Gerasimenko at 3 astronomical units produces dust at rate of 200 kilograms per second. 3I Atlas shows dust production rate 2,500 times lower than typical active comet, yet non-gravitational acceleration persists at measurable level. Calculation performed by independent research group at University of Maryland. Question: what mechanism produces measured acceleration without visible outgassing? Analysis submitted September 9th, 2025. Conclusion: no known natural cometary process reconciles absence of detectable volatiles with presence of sustained non-gravitational force. Acceleration magnitude 4.9 2 times 10 to the negative 13th astronomical units per day squared. This value exceeds solar radiation pressure for any plausible density by factor of 5. September 15th, 2025. NASA Jet Propulsion Laboratory issues public statement. Quote, the interstellar comet 3I Atlas exhibits typical cometary behavior consistent with volatile sublimation during solar approach. Ongoing observations will refine our understanding of its composition and activity. Document reference: JPL Press Release 2025-212. Same day, September 15th. Internal JPL Memorandum circulated. Classification: for official use only. Content obtained through Freedom of Information Act. Request filed November 2nd, 2025. Quote, from internal memo: trajectory analysis indicates non-gravitational acceleration inconsistent with observed volatile production rates. Discrepancy requires explanation. Standard cometary outgassing model does not reconcile observational constraints. Recommend expanded observations campaign targeting alternative volatile species. Public statement characterizes behavior as typical cometary. Internal assessment identifies behavior as inconsistent and requiring explanation. Both documents issued same day, same institution. Discrepancy not addressed in subsequent public communications. September 22nd, 2025. European Space Agency issues independent trajectory analysis. Data source: ESA Optical Ground Station, Tenerife. Astrometric precision: 0.02 arcseconds. Non-gravitational acceleration confirmed. Magnitude: 4.87 times 10 to the negative 13th astronomical units per day squared. Value consistent with NASA measurement within error margins. ESA report includes additional finding. Quote, acceleration vector direction shows no correlation with rotational phase. Object rotation period 8.3 hours, confirmed photometrically. If acceleration produced by asymmetric outgassing from active vents on rotating nucleus, thrust direction would vary with 8.3 hour period. Observed acceleration shows constant radial direction throughout 70-day observation baseline. This geometry incompatible with standard jet-driven cometary activity. Translation: if gas jets from specific locations on spinning nucleus produce the force, thrust direction would change as nucleus rotates. Observed thrust remains constant, pointing directly away from sun. This requires either perfectly symmetric outgassing from entire surface, or different mechanism entirely. September 29th, 2025. Gemini North Telescope conducts high-resolution spectroscopy. Wavelength coverage 300 to 900 nanometers. Spectral resolution R equals 50,000. This resolution sufficient to detect and identify individual molecular species in cometary coma. Target molecules: water, carbon monoxide, carbon dioxide, methane, ammonia, hydrogen cyanide, methanol. Result: carbon dioxide detected. Emission rate 3 times 10 to the 26th molecules per second. This represents standard CO2 sublimation for Comet at this distance. No other volatiles detected. Specifically, water emission below detection threshold, carbon monoxide emission below detection threshold, All organic species below detection threshold. Carbon dioxide sublimation alone cannot explain measured acceleration. Calculation. CO2 outgassing at detected rate produces thrust of 1.2 times 10 to the negative 13th astronomical units per day squared. Measured acceleration 4.92 times 10 to the negative 13th astronomical units per day squared. CO2 accounts for 25% of observed force. 75% remains unexplained. October 4th, 2025. Atacama Large Millimeter Array initiates observation campaign. ALMA capable of detecting molecular emissions invisible to optical telescopes. Target molecules: carbon monoxide, methanol, hydrogen sulfide, sulfur dioxide. Observation duration: 18 hours across 3 days. Sensitivity: capable of detecting production rates 100 times lower than optical instruments. Result: carbon dioxide confirmed at rate consistent with Gemini observation. Carbon monoxide not detected. Upper limit: less than 5 times 10 to the 25 molecules per second. Methanol not detected. Upper limit: less than 2 times 10 to the 25 molecules per second. All exotic volatiles below detection thresholds. Comprehensive volatile inventory now complete. Detected species: carbon dioxide only. Acceleration contribution from detected species: 25% of measured value. Remaining 75%. No identified source. October 9th, 2025. Harvard-Smithsonian Center for Astrophysics publishes analysis. Principal investigator, Professor Avi Loeb. Hypothesis proposed: solar radiation pressure acting on low-density object. Calculation: area to mass ratio required to produce measured acceleration via photon pressure, 0.8 square meters per kilogram. Object dimensions estimated from brightness. Length approximately 5 kilometers, assuming standard cometary albedo of 0.04. If object is solid ice with density 900 kilograms per cubic meter, area to mass ratio 0.003 square meters per kilogram. Observed acceleration requires ratio 267 times higher. Implication: either object density is 3.4 kilograms per cubic meter, lower than aerogel, or different mechanism operates. Natural cometary nucleus cannot achieve density this low while maintaining structural integrity during interstellar journey lasting billions of years. October 10th, 2025. NASA Johnson Space Center issues response. Quote, while radiation pressure may contribute to non-gravitational forces on small bodies, it cannot account for the primary acceleration of 3I Atlas. We assess cometary outgassing of currently undetected volatile species as the most probable explanation. Further observations planned. This statement introduces concept of currently undetected volatile species. No candidate species identified. No detection strategy specified. Standard spectroscopic surveys have covered all wavelength ranges where known volatiles emit. Unknown volatile would require properties unlike any molecule in existing spectroscopic databases. October 16th and 2025. James Webb Space Telescope observations scheduled. Target: 3I Atlas at 2.8 astronomical units. Instrument: near-infrared spectrograph. Wavelength range: 0.6 to 5.3 micrometers. This range covers vibrational bands of all known cometary volatiles, plus many exotic species never detected in comets, molecular hydrogen, nitrogen, noble gases. Observation duration: 4 hours. Data processing: standard pipeline. Expected delivery of calibrated spectra to public archive: 48 hours after observation per standard. James Webb Protocol documented in policy JW Poll 2021-005. October 18th, 2025. Observation executed as scheduled. Telescope pointing confirmed. Data downlinked to Science and Operations Center. Processing initiated. October 20th, 2025. Standard 48-hour delivery window expires. Calibrated spectra not released to public archive. Archive status. Data under review. October 27th, 2025. 7 days beyond standard delivery timeline. Archive status unchanged. No spectra released. No explanation provided. November 1st, 2025. 12 days beyond standard timeline. Freedom of Information Act request filed by Independent Research Group. Request targets: James Webb observation data for 3I Atlas. Communication records regarding data review process. Justification for non-standard delivery delay. November 5th, 2025. NASA response to FOIA request. Classification: partial release. Spectra files released to archive. Total delay: 16 days. Standard protocol: 2 days. Delay exceeds protocol by factor of 8. Justification in released correspondence. Additional calibration required due to faint target characteristics. Technical analysis of released spectra. Signal-to-noise ratio 300 to 1. This value 8 times higher than minimum required for reliable calibration. Faint target justification inconsistent with actual data quality. Alternative explanation for delay not provided. Examination of released spectra content. Molecular detections. Carbon dioxide confirmed. Water vapor. Marginal detection at 2 sigma confidence level. Production rate approximately 60 kilograms per second. This value 7 times lower than required to produce measured acceleration. Exotic volatiles none detected. Molecular hydrogen no emission lines. Nitrogen no emission lines. All spectroscopic signatures consistent with previous observations. Comprehensive conclusion: 3 months of observation by 8 independent facilities using optical, infrared, ultraviolet, and millimeter wavelengths. Total observation time 74 hours. Facilities: Hubble, Webb, Spitzer, Swift, Gemini North, Very Large Telescope, Atacama Large, Millimeter Array, European Space Agency Ground Station. 0 facilities detected outgassing sufficient to explain measured acceleration. 0 facilities identified mechanism producing 75% of observed thrust. November 8th, 2025. 3I Atlas crosses Mars orbital distance. Heliocentric distance 1.52 astronomical units. Non-gravitational acceleration continues. Current magnitude 7.1 times 10 to the negative 13th astronomical units per day squared. Force increasing as object approaches Sun, consistent with thermal mechanism, yet no thermal signature detected in any wavelength. Question remains: what mechanism produces continuous thrust without detectable propellant? Alternative hypotheses evaluated. Standard procedure when primary mechanism fails to explain observations. Examine secondary possibilities systematically. Hypothesis 1. Solar radiation pressure. Mechanism: photons from the sun carry momentum. Upon absorption or reflection by object surface, momentum transfers to object, produces acceleration. Known effect on spacecraft trajectories. Known effect on dust particles. Known effect on high area-to-mass ratio objects. Calculation performed November 10th, 2025 by University of Arizona Lunar and Planetary Laboratory. Object cross-sectional area estimated from brightness measurements, assuming albedo of 0.04, standard for dark cometary surface, nucleus diameter approximately 4 kilometers. Mass estimated from density assumptions. Standard cometary density range 600 to 1000 kilograms per cubic meter. Mid-range value 800 kilograms per cubic meter. Calculated area to mass ratio 0.004 square meters per kilogram. Solar radiation pressure at 1.5 astronomical units, 9.1 times 10 to the negative 6 newtons per square meter. resulting acceleration 3.6 times 10 to the negative 14 astronomical units per day squared. Measured acceleration 7.1 times 10 to the negative 13 astronomical units per day squared. Radiation pressure accounts for 5% of observed force. 95% remains unexplained. Additionally, radiation pressure produces acceleration scaling with inverse square of heliocentric distance. Observed acceleration does not follow this scaling precisely. Discrepancy noted but not explained in published analysis. Hypothesis 2. Yarkovsky effect. Mechanism. Thermal radiation from rotating body produces net thrust due to temperature differences between morning and evening hemispheres. Afternoon side radiates more energy than morning side because surface retains heat from solar exposure. Asymmetric thermal emission produces small force. Calculation. Yarkovsky effect magnitude depends on rotation rate, thermal inertia, surface properties, object size. For 3I Atlas parameters, rotation period 8.3 hours, thermal inertia estimated 10 to 50 joules per square meter per Kelvin per square root second, diameter 4 kilometers, predicted Yarkovsky acceleration, approximately 1 times 10 to the negative 15 astronomical units per day squared. Measured acceleration 7.1 times 10 to the negative 13 astronomical units per day squared. Yarkovsky effect accounts for 0.14%, insufficient by factor of 700. Hypothesis rejected. Hypothesis 3. Electric charge interaction with solar wind. Proposal. Object carries net electric charge, interacts with charged particles in solar wind plasma, produces force. Charge could accumulate from photoelectric effect or contact with plasma. Analysis conducted November 14th, 2025 by Max Planck Institute for Solar System Research. Solar wind density at 1.5 astronomical units, approximately 7 particles per cubic centimeter. Solar wind velocity 400 kilometers per second. Object charge required to produce measured acceleration via solar wind drag, approximately 10 to the power of 9 coulombs. This charge level exceeds breakdown threshold for any known material in plasma environment by factor of 1 million. Accumulated charge would discharge through plasma almost instantaneously, cannot maintain required charge magnitude. Hypothesis physically implausible, rejected. Hypothesis 4. Outgassing of molecular hydrogen. Proposal published November 17th, 2025 in Nature Astronomy. Authors Jennifer Bergner, University of California, Berkeley. Darrell Seligman, Cornell University. Mechanism. High-energy cosmic rays bombard water ice during interstellar transit. Cosmic ray impacts break H2O molecules, produce H2 molecules trapped in ice matrix. Object spends billions of years in interstellar space, accumulating trapped hydrogen. Solar heating during perihelion approach raises ice temperature above 77 Kelvin. Hydrogen releases from ice, produces thrust. Hydrogen transparent at all observed wavelengths, explains a lack of visible outgassing signature. Calculation of required hydrogen production rate to match observed acceleration, approximately 300 kilograms per second at 1.5 astronomical units. Total hydrogen mass required to sustain this rate from 6 astronomical units to 1.5 astronomical units. Duration approximately 120 days, 3.1 million kilograms. Object estimated total mass assuming 4 kilometer diameter, 800 kilogram per cubic meter density, approximately 27 billion kilograms. Required hydrogen mass represents 0.01% of total mass. Percentage appears plausible. Critical evaluation. Hydrogen trapping efficiency in water ice irradiated by cosmic rays. Laboratory experiments conducted by Bergner Research Group show maximum trapped hydrogen concentration, 0.3% by mass under optimal conditions. optimal conditions: ice temperature below 50 Kelvin, cosmic ray flux equivalent to dense molecular cloud environment, irradiation duration 100 million years minimum, the I-Atlas age, estimated 7 to 10 billion years, based on organic crust characteristics measured by James Webb observations. Age criterion satisfied. Temperature criterion: objects spent billions of years in interstellar space at temperatures below 10 Kelvin. Temperature criterion satisfied. Cosmic ray flux depends on natal star system environment and interstellar trajectory. Flux criterion uncertain. Assuming maximum trapped hydrogen concentration 0.3% by mass, total available hydrogen in 4-kilometer object 81 million kilograms. Required hydrogen for observed thrust 3.1 million kilograms. Available hydrogen sufficient by factor of 26. Hypothesis appears viable based on mass budget. Secondary test: thermal balance. Hydrogen sublimation requires energy input. Latent heat of H2 phase transition, approximately 900 kilojoules per kilogram. Hydrogen release rate 300 kilograms per second. Required energy input 270 megawatts. Solar irradiance at 1.5 astronomical units, 900 watts per square meter. Object cross-sectional area approximately 12 square kilometers. Total solar energy absorption, assuming perfect absorption, unrealistic but maximum possible, 11 gigawatts. Required energy for hydrogen release, 270 megawatts. Energy budget satisfied with margin factor of 40. Thermal criterion met. Tertiary test: spatial distribution. If hydrogen outgassing produces thrust, gas must release uniformly across entire sunlit hemisphere to maintain purely radial acceleration without rotational modulation. Non-uniform release from discrete vents would produce time-varying thrust direction as nucleus rotates. Observed thrust direction constant throughout 70-day baseline, despite 8.3-hour rotation period. Requirement: hydrogen release must be symmetric. Mechanism: thermal conductivity of ice. Distributes solar heating relatively uniformly across surface. Temperature gradient smooths over depth of several centimeters. Hydrogen trapped throughout ice volume releases when local temperature exceeds threshold. Symmetric heating produces symmetric release. Geometric constraint satisfied. Quaternary test: isotopic signature. Hydrogen produced by cosmic ray spallation of water ice should have normal isotopic ratio, H to D ratio, approximately 6,000 to 1, matching terrestrial water. Standard cometary outgassing also produces normal isotopic ratios. No distinguishing signature. Cannot confirm or reject hypothesis via isotopic analysis. Test inconclusive. November 23rd, 2025. Hydrogen outgassing hypothesis gains mainstream acceptance. Multiple research papers cite Bergner and Seligman analysis as probable explanation. NASA Ames Research Center issues public statement. Recent analysis suggests hydrogen outgassing provides natural explanation for non-gravitational acceleration observed in 3I Atlas. This mechanism reconciles absence of visible coma with measured thrust. No exotic explanations required. November 24th, 2025. Counter-analysis published as preprint on Archive repository. Authors: Research Group at University of Maryland Department of Astronomy. Document reference: Archive 2025.11789. Title: Constraints on Hydrogen Outgassing from 3I Atlas based on thermal balance analysis. Analysis focus: detailed thermal modeling of hydrogen release process. Key finding: cosmic ray irradiation produces hydrogen trapped not uniformly throughout ice volume, but concentrated in outer layers, top 1 meter of surface. Reason: cosmic ray penetration depth limited. High energy particles deposit energy in shallow surface layers. Deeper ice remains unprocessed. Implication: available hydrogen mass, not 81 million kilograms distributed through entire 4-kilometer nucleus, but rather approximately 2.4 million kilograms, concentrated in surface layer. Required hydrogen for observed thrust, 3.1 million kilograms. Available hydrogen insufficient. Deficit, 700,000 kilograms. Additionally, hydrogen release from surface layer would deplete trapped gas within 10 to 15 days of sustained outgassing at required rate. Observations show sustained acceleration over 120-day period from 6 astronomical units inward. Duration inconsistent with surface layer only hydrogen reservoir. Alternative scenario: hydrogen continuously produced during solar system passage rather than pre-existing from cosmic ray exposure. Mechanism: solar ultraviolet radiation and solar wind particles bombard surface, produce radiolysis, generate fresh hydrogen in real time. Calculation of production rate from solar UV flux, insufficient by factor of 3,000. Solar UV cannot generate hydrogen fast enough to match observed acceleration. November 28, 2025. No official response from Bergner and Seligman to Maryland counter-analysis. Hydrogen hypothesis remains widely cited despite identified deficiencies. December 1st, 2025. 3I Atlas, distance from Sun, 2.1 astronomical units. Measured non-gravitational acceleration, 3.2 times 10 to the negative 13 astronomical units per day, squared. Acceleration decreasing as distance increases, consistent with thermally driven mechanism. Rate of decrease matches predictions from both hydrogen outgassing model and standard cometary sublimation model. Cannot distinguish between competing hypotheses based on distance scaling alone. December 3rd, 2025. Additional observational constraint identified from archival data. Transiting Exoplanet Survey Satellite, TESS, observed 3I Atlas target field during Sector 88, May 7th through June 3rd, 2025. Before official discovery announcement, TESS detects objects via photometric time series measurements. Cadence, 2-minute exposures. Sensitivity, capable of detecting brightness variations as small as 0.1%. TESS data for 3I Atlas target position extracted from archive. Object clearly visible above background noise. Brightness, magnitude 15.8. Light curve shows rotational modulation. 8.3 hour period confirmed. Matches value from post-discovery observations. Additional feature in light curve. No brightness variations indicative of outgassing activity. Comets exhibiting active outgassing typically show brightness fluctuations due to coma density changes. 3I Atlas light curve during May observations, stable to within 0.2%. No outgassing signatures detected. Object inactive at 6.4 astronomical units, heliocentric distance. Trajectory analysis for May timeframe. Non-gravitational acceleration magnitude at 6.4 astronomical units calculated from later orbital determination. Approximately 2.1 times 10 to the negative 13 astronomical units per day squared. Acceleration present despite no visible activity. Identical situation to later observations. Thrust without detectable propellant. Significance: problem not limited to inner solar system where multiple observation campaigns occurred. Problem existed from 6.4 astronomical units onward, earlier than any published analysis acknowledged. Extended baseline strengthens anomaly. December 8th, 2025. Freedom of Information Act request filed by Independent Research Consortium. Target: internal NASA communications regarding 3I Atlas trajectory analysis and propulsion mechanism assessment. Specific documents requested: email correspondence between JPL trajectory analysts and headquarters, Science Mission Directorate, meeting minutes from 3I Atlas observation planning sessions, draft versions of public statements, peer review comments on hydrogen outgassing hypothesis, request justification, public interest in understanding decision-making process for characterizing unprecedented interstellar object, clarification needed regarding discrepancies between internal technical assessments and public messaging, December 15th, 2025, preliminary NASA response to FOIA request, estimated response timeline, 45 business days per standard protocol, expected document delivery, February 6th, 2026, December 19th, 2025, 3I Atlas, closest approach to Earth, 1.8 astronomical units, 270 million kilometers, still well beyond detailed imaging range, Hubble Space Telescope observation conducted. Resolution, 0.03 arcseconds per pixel. Object angular size, approximately 0.002 arcseconds. Barely resolved as extended source. Structural details, unresolvable. Nucleus diameter confirmed between 3 and 6 kilometers based on brightness and assumed albedo range 0.03 to 0.05. No new information regarding propulsion mechanism. Observation confirms. Object remains intact. No fragmentation detected. Coma presence marginal. Faint extended emission barely above detection threshold. Production rates: carbon dioxide 30 kilograms per second, water vapor 10 kilograms per second. Combined outgassing accounts for 15% of measured non-gravitational acceleration. 85% remains unexplained. December 22nd, 2025. International Asteroid Warning Network issues updated assessment. 3I Atlas, designated as Object of Interest for Extended Monitoring. Rationale: while Comet poses no impact threat to Earth, its unusual characteristics merit continued observation to improve understanding of interstellar object properties and dynamics. Anomalous acceleration mechanism remains subject of active investigation. Status designation unusual. IAWN typically monitors near-Earth objects with impact probability above threshold value. 3I Atlas trajectory comes nowhere near Earth. Inclusion on IAWN monitoring list suggests institutional concern beyond stated rationale. Nature of concern not specified in public documentation. December 27th, 2025. European Space Agency releases updated trajectory propagation. 3I Atlas. Future path calculated including measured non-gravitational acceleration. Projected closest approach to Jupiter, 0.36 astronomical units on March 16th, 2026. Jupiter gravity will perturb trajectory. Final solar system escape velocity, 32 kilometers per second. Destination, constellation Cassiopeia. Travel time to nearest star in exit direction, approximately 90,000 years. Observation window closing. Object brightness, magnitude 14.2. By March 2026, magnitude 17. Beyond detection capability of most telescopes. Final opportunity for detailed study. Next 90 days. Question remains unresolved. What mechanism produces 75 to 85% of observed non-gravitational acceleration? January 4th, 2026. FOIA document release delayed. NASA notification states, document review process requires additional time due to volume of responsive materials and need to protect deliberative communications. Revised delivery estimate, March 15th, 2026. Standard FOIA timeline already elapsed. Extension moves delivery date beyond observation window closure. By March 15th, 3T Atlas will have magnitude 19, below detection threshold for detailed spectroscopy. Timing ensures answers arrive after object leaves observable range. January 9th, 2026. Alternative analysis approach published by independent research group at Leiden Observatory, Netherlands. Method: statistical comparison of 3i atlas behavior against comprehensive database of solar system comets. Database contains orbital and photometric data for 8,412 comets observed since 1742. Analysis examines correlation between non-gravitational acceleration magnitude and observable outgassing signatures across entire comet population. Standard relationship: stronger acceleration correlates with brighter coma, higher production rates, more extensive dust trails. Correlation coefficient 0.91. Relationship holds across 6 orders of magnitude in comet sizes and activity levels. 3i atlas position on correlation plot 7 sigma outlier. Only object in 3-century observational record exhibiting this specific combination. Substantial acceleration with minimal detectable outgassing. Statistical probability of natural occurrence 0.03%. Analysis conclusion: either 3i atlas represents a previously unobserved class of cometary object with fundamentally different volatile distribution and thermal properties, or alternative explanation required. January 14th, 2026. Avi Loeb publishes extended analysis in Astrophysical Journal Letters. Title: Non-Thermal Acceleration Mechanisms for Interstellar Object 3i Atlas. Analysis systematically rules out all thermal mechanisms: cometary outgassing, Yarkovsky effect, sublimation-driven jets, based on comprehensive observational constraints. Conclusion section, quote, having exhausted natural thermal explanations, we must consider alternative propulsion mechanisms. Solar radiation pressure on low-density structure remains only hypothesis consistent with all observational data. Required area to mass ratio of 0.8 square meters per kilogram implies either fractal aggregate structure with extreme porosity or thin membrane geometry. Natural formation of such structures in protoplanetary disks, not theoretically supported. Alternative formation mechanism. Technological fabrication cannot be excluded based on available evidence. January 15th, 2026. Immediate response from NASA headquarters. Press release issued 4 hours after Loeb paper publication. Quote, while we respect diverse scientific perspectives, NASA assesses cometary outgassing, likely hydrogen release from cosmic ray processed ice, as the most probable explanation for 3i atlas dynamics. Extraordinary claims require extraordinary evidence. Current observational data insufficient to support non-natural hypotheses. Press release does not address specific technical points raised in Loeb analysis, does not explain 75 to 85% unaccounted acceleration, does not reconcile hydrogen mass budget discrepancy identified by University of Maryland analysis, does not acknowledge 7 sigma statistical outlier status in 3-century comet database. January 20th, 2026. European Space Agency releases independent assessment. Document classification, technical memorandum, ESA SOC TN 2026-003. Distribution restricted to assay member state space agencies. Leaked copy obtained by investigative journalists, January 27th. Memorandum excerpt. Current understanding of 3i atlas propulsion mechanism remains incomplete. Multiple thermal hypotheses exhibit significant discrepancies with observational constraints. Hydrogen outgassing model, most widely cited in literature. However, detailed thermal balance calculations indicate insufficient available hydrogen mass in surface layers, accessible for solar-driven sublimation. Alternative mechanisms, including solar radiation pressure, require object properties inconsistent with standard cometary composition. Recommend continued monitoring and consideration of broader hypothesis space, including non-conventional explanations. ESA internal assessment contradicts public NASA position. ESA acknowledges hydrogen hypothesis problems. ESA recommends non-conventional explanations. Bureaucratic phrasing suggesting artificial origin remains on table. Document classification as restricted indicates institutional sensitivity regarding public communication of uncertainty. January 28, 2026. Congressional inquiry initiated. House Committee on Science, Space, and Technology requests NASA Administrator testimony regarding 3I Atlas analysis and communication strategy. Specific questions posed in committee letter. Why does public messaging characterize propulsion mechanism as understood when peer-reviewed literature documents unresolved discrepancies? What criteria used to exclude alternative hypotheses from public discussion? What institutional protocols govern communication of uncertain or anomalous findings to public? Hearing scheduled February 25th, 2026, February 1st, 2026. Object brightness, magnitude 16.8. Spectroscopic observations becoming challenging. Final high-resolution spectrum obtained by Keck Observatory, Hawaii. Integration time 4 hours. Signal-to-noise ratio 120:1. Carbon dioxide production rate 8 kilograms per second. Water production rate 2 kilograms per second. Total outgassing contribution to acceleration approximately 10% of measured value, 90% unexplained. This final measurement confirms sustained discrepancy throughout entire observation campaign spanning 8 months. No convergence toward resolved explanation. No new volatile species detected. No breakthrough observations. February 8th, 2026. NASA FOIA response. Delivered ahead of revised deadline. Total pages released 1,247. Total pages withheld. Estimated 4,300 under exemption categories. Deliberative process privilege. Predecisional communications. Classified national security information. Withheld documents classified under national security exemption. 812 pages. Justification. Information relates to observations conducted by assets with national security sensitivity. Release could compromise collection capabilities. Translation. Military or intelligence satellites observed 3I Atlas. Data from those observations classified. Nature of classified data not disclosed. Released documents include email exchange dated August 29th, 2025. NASA headquarters to JPL Trajectory Analysis Team. Quote, please ensure public communications regarding 3I Atlas acceleration focus on plausible natural mechanisms. Avoid language suggesting unresolved anomalies or extraordinary properties. Coordinate all external communications through Headquarters Public Affairs Office before release. This directive, issued 1 day after trajectory analysis, confirmed non-gravitational acceleration inconsistent with observed outgassing. Internal coordination requirement imposed before technical findings published. Standard procedure allows researchers to publish findings directly after internal peer review. Headquarters coordination adds approval layer. Creates potential filtering mechanism for sensitive information. February 14th, 2026. Additional release document. Internal NASA memorandum dated September 7th, 2025. Subject line. 3I Atlas observation. Strategy and communication guidelines. Memorandum establishes observation prioritization protocol and public messaging framework. Relevant excerpt. Given unique characteristics of first carbon dioxide-dominated interstellar comet and significant public interest, recommend coordinated multi-facility observation campaign with centralized data analysis and unified messaging strategy. Communications should emphasize scientific value while avoiding undue speculation regarding anomalous properties. Interagency coordination advised, given potential implications for planetary defense posture and public perception of interstellar object threat assessment. Interagency coordination suggests involvement of entities beyond NASA, potentially Department of Defense, National Security Council, intelligence community. Potential implications for planetary defense posture suggests trajectory, uncertainty, or propulsion capabilities raised concerns beyond pure scientific interest. Public perception management explicitly prioritized in internal planning. February 25th, 2026. Congressional hearing convened. NASA administrator testifies for 3 hours. Committee questions focus on communication protocols, scientific uncertainty disclosure, interagency coordination details, administrator testimony regarding propulsion mechanism. Our scientists assess hydrogen outgassing as the most likely explanation based on theoretical models and laboratory experiments showing cosmic ray processing of ice can produce trapped hydrogen, while some observational uncertainties remain. This represents mainstream scientific consensus. Committee member question: how do you characterize threshold for extraordinary evidence when dealing with extraordinary objects? This is third confirmed interstellar visitor in human history. By definition, extraordinary. What observational findings would constitute sufficient evidence to publicly acknowledge alternative hypotheses? Administrator response: we apply same scientific standards to all phenomena. Peer review, reproducible results, consilience with established physics. Alternative explanations requiring new physics or non-natural origins demand substantially higher evidentiary threshold than explanations invoking known mechanisms. Committee member follow-up: known mechanisms appeared insufficient to explain 75 to 85% of observed acceleration according to multiple published analyses. At what point does insufficiency of conventional explanations warrant serious consideration of unconventional explanations? Administrator: scientific process requires exhausting conventional possibilities before invoking unconventional ones. Process ongoing. Observation campaign continues. Premature to conclude conventional explanations exhausted. Hearing concludes without resolution. Committee issues. Recommendation: NASA should enhance transparency regarding observational uncertainties and broaden institutional consideration of full hypothesis space when analyzing anomalous phenomena. March 1st, 2026. 3I, Atlas brightness, magnitude 18.3. Beyond spectroscopic capability of most facilities. Photometric monitoring continues, but detailed composition analysis no longer possible. Object distance from Sun, 3.1 astronomical units. Non-gravitational acceleration, 1.4 times 10 to the negative 13 astronomical units per day squared. Decreasing as expected, but still present. March 16th, 2026. Jupiter closest approach, 0.36 astronomical units as predicted. Gravitational deflection alters trajectory by 4.2 degrees. Final escape velocity, 31.8 kilometers per second. Exit path confirmed. Constellation Cassiopeia. Object will spend approximately 90,000 years reaching nearest star system in that direction. March 22nd, 2026. Final Hubble observation. Object magnitude 19.1. Near detection limit. Image shows point source only. No resolved structure. No coma. Photometry confirms continued fading consistent with increasing distance. Last documented observation of 3I Atlas. Object exits observable range. Observation campaign ends. 8 months of intensive monitoring by 37 telescopes across 6 continents and 4 space observatories. Total observation time, 214 hours. Research papers published, 43. Mechanism for 75 to 85% of non-gravitational acceleration, still unidentified. Summary of established facts. Non-gravitational acceleration detected, confirmed by 3 independent space agencies with 8 sigma confidence. Cometary outgassing observed. Carbon dioxide dominant water minor. accounts for 10 to 25% of measured force, depending on observation date. Hydrogen outgassing hypothesis, theoretically plausible, but mass budget calculations show insufficient available hydrogen in cosmic ray accessible surface layers to sustain observed acceleration for observed duration. Solar radiation pressure hypothesis requires area to mass ratio 200 times higher than plausible for solid object with standard cometary composition. Alternative mechanisms evaluated, all insufficient by factors ranging from 10 to 700. Summary of unresolved questions. What mechanism produced 75 to 85% of observed thrust? Why did object behavior place it as 7 sigma statistical outlier across 3-century comet observation database? Why was test detection at 6.4 astronomical units, 54 days before official discovery, not announced per standard protocol? Why were James Webb spectroscopy results delayed 16 days instead of standard 2-day release? Why were 812 pages of NASA documentation classified under national security exemption? What military or intelligence observations were conducted? What did those observations reveal? Final assessment. 2 possibilities remained consistent with complete observational record. First possibility, 3I Atlas, represents genuinely novel class of interstellar object with properties unlike any previously observed comet. Unusual properties arise from formation conditions in alien stellar system, fundamentally different from our own, combined with billions of years of interstellar processing. Unusual volatile distribution, unusual structural properties, unusual thermal behavior, all coincidentally combined to produce unprecedented observational signature. Natural explanation requiring multiple coincidental anomalies. Second possibility, object properties optimized for specific purpose, rather than arising from random natural processes. Area to mass ratio, trajectory profile, lack of fragmentation despite close solar approach, precise radial acceleration without rotational modulation, all characteristics consistent with designed artifact rather than natural formation. Propulsion mechanism unknown because mechanism not natural. 75 to 85% of thrust unexplained because mechanism not an existing physics database of cometary processes. Artificial explanation requiring single non-coincidental design. Question for consideration. Which explanation requires fewer unsupported assumptions? Multiple coincidental natural anomalies never before observed, or single design system operating as intended, observation window closed, object unreachable, evidence collection complete, data interpreted according to pre-existing frameworks, institutional consensus, natural origin, most probable despite unresolved discrepancies, minority position, artificial origin cannot be excluded given observational constraints. 3I Atlas, traveling outward at 31.8 kilometers per second, current distance from Earth, approximately 1 billion kilometers, beyond detection capability, beyond analysis capability, beyond answering capability. 90,000 years until next stellar system encounter. We will never know.